Hey programmers, Alvin here. Right now I want to walk through this intersection problem. So let's take a look at what this problem's asking us to do. Short story is we want to take in two arrays as inputs. So you have an array of 4, 2, 1, 6, and also another array of 3, 6, 9, 2, 10. And what I want to do is return a new array containing the elements that are common to both. In other words, I want to return their intersection. So in this particular example, the common elements would be 2 and also 6. And in the prompt, they also tell us that, hey, it doesn't really matter the order in which I return the elements, as long as I include the correct elements. So how can we go about solving a problem like this? So I think to get the ball rolling on this one, why don't we just go for any solution, right? So we won't even need to really care about the efficiency for now. So really the most straightforward idea is to recognize that, hey, what you're really looking for is elements that are common to both, right? In other words, as I iterate through one list, I can search for that element in the other list. And if I find an element that's in definitely both of the arrays, then that's going to contribute to my output. So maybe we'll step through this one a little more slowly. So just rearrange these two input arrays. And over time, I'm going to accumulate the intersection. So I can probably implement this with just some form of nested loops. So I'm going to start some loop that iterates through my first array, and another loop that iterates through my second array. And I'm going to do a comparison, right? So I'm going to check, is 4 the same as 3? It's not, so I keep going, right? Is 4 the same as 6? Is 4 the same as 9? And 2 and 10 and so on, right? So for every element of my first array, I'm going to compare it against every element of my second array. So after I complete this first pass, I actually don't find any common elements, so the intersection stays empty. Then I'm going to move to my second element of array 1, and I do similar comparisons, right? Is 2 equal to 3? Nope. Is 2 equal to 6? Nope. Is 2 equal to 9? Nope. And then finally, I have a first instance where I find a common element, right? 2 is equal to 2, so I'm going to add that to my intersection. Now I would just continue this process for the rest of the elements in my arrays. And eventually I'm going to spot that, hey, the other common element is also 6. So I would add that into my intersection. So that's a pretty straightforward algorithm to implement, just a form of nested loops. But what's the complexity of a strategy like this? You can probably already see it. Let me give myself some terms to describe my inputs. So in this problem, I have two inputs, right? One for my array 1 and another for my array 2. And I'll label them as n and m respectively, right? So those represent the lengths of my input arrays. And based on the flow we just stepped through, it's pretty clear to me that because I have nested loops, the time complexity would seem to be an n times m, right? Whenever I have nested code, that tends to appear in my complexity as a multiplication, right, of my factors. And then along with that, what's the space complexity? Well, it's really just going to be the space, I guess, for the output here, which would probably be the minimum length between n and m, right? Because imagine, in terms of the size of my output, the intersection of two arrays is never going to be more than the smallest array, right? Because by definition, common elements must appear in both, right? So in the worst case scenario, the space used up by our output would just be the length of the smaller array in the worst case. So this solution would definitely work, but I think in most interview scenarios, this wouldn't really be a really practical time complexity. There's a pretty straightforward solution that should run in actually a faster time. That being said, I'm pretty happy with our space complexity. We probably can't do any better than the space complexity. So let's figure out how we can cut down on some of the time here, right? So we know that this algorithm is slow because we use nested loops. So the key to make it fast is just to not use nested loops, right? So the trick is to use some sort of a hashed data structure. I'll refer to it as a set. So depending on your language of choice, your language might have like an unordered set or just a regular set object. Really what I'm looking for is a hash data structure that has a constant time lookup. So for the first part of this adjusted algorithm, I can just take the elements of, let's say, my first array and just store them all within my set. So that's a pretty straightforward process, just taking every element and inserting it into my set. And so far, I've just iterated through my first array. And when I add an element to the set, inserting a single element into a set actually runs an O of 1 time. So I haven't actually slowed down my code at all quite yet. And so now that I have this set, right, looking up data within this set is going to be interpreted as O of 1 lookup because it's a hash data structure. And so in the final step of my algorithm, I just need to iterate through my second array separately and check if the elements of my second array are contained in the set. So I have this element of 3 I'm iterating through for my second array. I check, is 3 within my set? It's not, so it's not part of the intersection. But I go into the next element of 6. Is 6 in my set? It is, so I add that into my intersection. And I continue this process for every element of array 2. So 9 is not in my set, but 2 is in my set, so I add it to the intersection. Finally, 10 is not in my set. And again, really, really important insight is when I do this lookup step inside of the set, that itself is O of 1. So when it comes to the complexity of this, we'll still say that n is the length of our array 1 and m is the length of array 2. Our time complexity would now be n plus m, right? The n comes from inserting all of the elements of array 1 into the set, and the m comes from us just iterating through all of the elements of array 2 separately, right? So it's not nested loops. In the context of my code, this would probably appear as 2 separate loops, one after the other. And so because of that, I now add these 2 terms, right? In general, when I have code like sequentially, then I would add the terms. But if I have it nested, I multiply it. And same story as before, the space complexity is just going to be some sort of linear factor. Here we can just say it's O of n because I have to convert all of the elements of array 1 into my set. And it doesn't really matter whether you choose to convert array 1 or array 2 into your set, right? In any case, you would just iterate over the other array in the long run. And so this is a pretty efficient solution. Let's go ahead and I want you to give it a shot. Try to implement this one on your own, but don't forget, we also have the video walkthrough with all of the code coming right up as well. But give it a go.